All right, this page 3 and 4 of the quiz review for chat 5 and 6. We're given a velocity equation here of negative 10 e to the negative 0.5 t. I'm going to try to do this without a calculator as much as I can. When I need one, I'll go ahead and use it. So it says, in what direction is the particle traveling? So this is determined by whether velocity is positive or negative at 3 seconds. So if I put 3 in for velocity, I'm going to get negative 10 times e to the negative 1.5. Now you got to be real careful here. E to the negative 1.5 simply means e to the 1.5 on the bottom, right? And e is a positive number raised to a 1.5 is going to keep it positive. This is a negative divided by positive. This is going to be negative, less than 0. So because the velocity at 3 seconds is less than 0, this is moving to the left. Left because velocity at 3 is less than 0. Okay. Now, if you have a calculator, obviously you can put it in and make sure you're right, but without a calculator, this is how you'd have to do it. Now, B says if the particle was at a position of negative 10 at 0, where is it at t equal 3? So here's our starting position, negative 10. This is where we start. And I want to know, how did the position change? In order to do change in position, I take the integral from start to finish of velocity. Okay. Now, I can do that without a calculator here. It would be negative 10 plus, and I'd have the integral 0 to 3 of negative 10 e to the negative 0.5 t. I'd have to do a u sub here. So I'd have to take that out. I have to go through it. Would they ask you to do that on an AP? Possibly. Possibly they'd want this 0.5 t, and then du is negative 0.5 dt. So dt is du divided by negative 0.5, which is negative 2 du. And so if we came back, this would be negative 10 plus the integral, and then I have to change these to u limits. So the 3 would now be negative 1.5. The 0 would stay 0. And this would be negative 10, which I'll pull out front, e to the u times dt, which is negative 2 du. So I'm going to have a negative 2 du. Now that negative 2 can come out here and join this. So this would be negative 10 plus 20 now, times the integral of e to the u, which is e to the u, from negative 1.5 to 0. Okay? Which ends up giving us negative 10 plus 20 times e to the negative 1.5 minus e to the 0, right? And that e to the 0 is 1, so we have to make sure it's in there. This would be our answer, right? Now, if we have a calculator, for heaven's sakes, we'll just do it from here, right? Put it right in the calculator. Should give us the same value. But without a calculator, that's how we'd have to go. Right. C says, is the particle speeding up or slowing down? Now, we've already said the velocity at 3 seconds is negative. Now, what we have to do is compare that to acceleration. So I'm going to find a formula for acceleration. Acceleration is the derivative of this. So it'll be negative 10 times the derivative of e is just that, times the derivative of the exponent, which is a negative 0.5. If I work that out a little bit cleaner, it's 5e to the negative 0.5t. Okay? That's my acceleration. Now, the acceleration at 3 seconds is equal to 5 times e to the negative 1.5, which is 5 over e to the 1.5, which will be positive. So I have a negative velocity, I have a positive acceleration. So we are slowing down because velocity at 3 seconds and acceleration at 3 seconds have opposite signs. D says find the limit of the velocity as t goes to infinity. In other words, you have your velocity, negative 10 e to the negative 0.5 t. What happens if we let t get super big? All right? What's going to happen if we let t just keep getting bigger and bigger and bigger? Well, this goes negative 10 over e to the 0.5 t. So if I let t get big, then e to the super big, that's also going to be super big. What I'm going to have is negative 10 divided by super big number, right? And if I have negative 10 divided by a super big number, that's going to go to 0. That's our answer to that. All right, then we have some integrals to do here, and a bunch of them use u sub and whatnot. So we'll start with number 8 here. So I'm going to do a u sub on that one. The u is going to be 5x squared minus 15x. That means du is going to be 10x minus 15, okay? dx, which means dx is du over this. Now I'm going to pull a 5 out of that, and we're going to have 2x minus 3 left over. And it's going to be important for going forward here. So up top I have this 4x minus 6. I'm going to pull a 2 out of that over this, which is u, times dx, which is du over 2x minus 3. See how the 2x minus 3 is now canceled? That's a big thing. Pull the 2/5 out front. It's going to be the integral of 1 over u du. That's going to be 2/5 times the natural log of the absolute value of u, 5x squared minus 15x, plus c. That'd be our answer there. For number 9, again, we're going to have a u sub here. The u is going to be x minus 3. I don't want the whole thing squared. I think that's a little too much. We're going to just have it be x minus 3. du will be dx, so that'll be an easy transition. We are going to have to do one thing, though, on the top there, which is a resubstitute. We're going to have x equals u plus 3 so that we can get rid of that, because it won't go away from the derivative. So this is going to give us the integral of, now e was an x limit, so I put it in. This is going to be e minus 3. 1 was an x limit. 1 minus 3 gives me negative 2. Okay, so I've switched those to u limits. 2 times x, 2 times u plus 3 over u squared du. All right, now, got a little bit of work to do. This is 2u plus 6. And what I'm going to do is divide both of those by u squared. So what ends up happening is I get, keep that for right now, I get 2u over u squared, which is 2 over u, and then plus 6 over u squared du. All right, now I'm ready to integrate. 2 over u is going to become 2 natural log u, absolute value, okay? 6 over u squared is 6u to the negative 2. When I integrate that, it's just a power rule. It's going to be 6u to the negative 1 over negative 1. So that over negative 1 makes this a minus, and that u to the negative 1, I'm just going to drop down there, okay? And we're doing this from e minus 3 to negative 2. So this is getting pretty crazy, I understand, but we're following the procedure. Now let's put this in. So I'm going to get 2 natural log of the absolute value of e minus 3 minus 6 over e minus 3. Okay, that's the top, minus the bottom, which is putting negative 2 in. 2 natural log 2 minus 6 over negative 2, which is negative 3, so this becomes plus 3. Pretty stupid looking, but that's our answer there. Right. For number 10, a little simpler. We had a u sub. The u is sine x. du is going to be cosine x dx. All right. So I have the integral of 5 cosine x times e to the u times dx, which is du over cosine x. The cosine x is canceled. Good. I get 5 times the integral of e to the u du, which is going to be 5e to the u, or e to the sine x, plus c. All right, and then over here, 11, I've got this one. And since 1 over x to the 4th is inside the e, I'm going to let that be the u. u is going to be x to the negative 4, this 1 over x to the 4th. Right? du will be negative 4x to the negative 5 dx, which means dx is going to be du divided by this. Now, when you divide by x to the negative 5, that just brings it up top, makes it x to the 5th, du over negative 4. Come on over here. We have the integral of e to the u over x to the 5th times dx, which is x to the 5th du over negative 4. X to the 5ths cancel. I get a negative 1/4 e to the u du. So I get a negative 1/4 e to the x negative 4 plus c. All right, not easy, challenging ones, but if we can do these well, then any of the other ones are going to feel pretty simple.